According to National Electrical Code Article 430.62, the rating of a motor feeder protective device is determined by adding the rating of the largest branch circuit protective device for any motor supplied by the feeder to the sum of the full load currents of all other motors supplied by that feeder. To properly size a motor feeder circuit breaker, you must consider both the full load currents of the motors and the ratings of their individual branch circuit protective devices. The methodology involves summing the full load currents of all motors connected to the feeder and adding the rating of the largest branch circuit protective device. This sum determines the minimum acceptable amperage rating for the feeder circuit breaker. For example, if you have a 480 volts panel supplying 225 horsepower soft starts, assuming each motor has a full load current of 34 amps and is fused for 51 amps. To determine the appropriate feeder breaker size, you would sum the full load currents of both motors, which is 34 amps plus 34 amps, and add the rating of the largest branch circuit protective device. Since both motors are fused at 51 amps, that value is added to the sum of the motor currents. This calculation results in 34 amps plus 34 amps plus 51 amps, totaling 119 amps. Therefore, a feeder circuit breaker rated for at least 119 amps would be required. The critical steps include, firstly, determining the full load current for each motor supplied by the feeder. This information can typically be found on the motor nameplate or in NEC tables. Secondly, identifying the rating of the branch circuit protective device, such as a fuse or circuit breaker, for each motor. Thirdly, summing the full load currents of all the motors connected to the feeder, excluding the motor with the largest branch circuit protective device. Finally, adding the rating of the largest branch circuit protective device to the sum of the full load currents calculated in the previous step. The result is the minimum required amperage rating for the feeder circuit breaker. It's important to note that this calculation provides the minimum acceptable rating. It may be necessary to increase the breaker size to account for factors such as motor starting currents, conductor ampacity, and voltage drop. Consult the NEC for additional requirements and considerations related to motor feeder protection. The NEC provides specific tables and guidelines for selecting appropriate conductor sizes and overcurrent protection devices based on motor characteristics and application. The importance of accurately calculating the motor feeder breaker size cannot be overstated. Undersizing the breaker can lead to nuisance tripping, interrupting power to critical equipment. Oversizing the breaker can compromise the protection of the motor and conductors, potentially leading to damage or fire. Therefore, it is essential to carefully follow the NEC guidelines and perform accurate calculations to ensure proper motor feeder protection. Moreover, consider directing factors for ambient temperature or conductor bundling, which can affect the ampacity of the conductors and the selection of the appropriate overcurrent protection. It is also important to consider the interrupting rating of the circuit breaker. The interrupting rating is the maximum fault current that the breaker can safely interrupt without failing. The available fault current at the panel must be determined to ensure that the selected breaker has an adequate interrupting rating. Available fault current studies should be performed to determine the maximum fault current at the location of the electrical panel. These studies take into account the utility source impedance, transformer impedance, and conductor impedance to calculate the available fault current. It is also recommended to consult with a qualified electrical engineer or electrician to ensure that the motor feeder circuit breaker is properly sized and installed in accordance with all applicable codes and regulations. This can ensure that the electrical system is safe and reliable. Furthermore, it is essential to consider the coordination of the overcurrent protection devices in the electrical system. Coordination ensures that the overcurrent protection device is closest to the fault will trip first, minimizing the impact on the rest of the system. Coordination studies should be performed to verify that the overcurrent protection devices are properly coordinated. These studies involve analyzing the time current curves of the overcurrent protection devices to ensure that they will trip in the correct sequence. Also remember to factor in any future expansion or changes to the motor loads on the feeder. It may be prudent to select a feeder breaker with a slightly higher rating to accommodate future growth. This can avoid the need to replace the breaker if additional motors are added to the feeder in the future. Motor feeders supplying multiple motors present unique challenges in terms of overcurrent protection. The NEC provides specific guidelines to address these challenges and ensure the safety and reliability of the electrical system. Adhering to these guidelines and performing accurate calculations are essential for properly sizing the motor feeder circuit breaker and protecting the motors and conductors from damage. In summary, the calculation and selection of a motor feeder circuit breaker requires careful attention to detail and a thorough understanding of the NEC requirements. The process involves determining the full load currents of all motors supplied by the feeder, identifying the rating of the largest branch circuit protective device, summing the full load currents and the largest branch circuit protective device rating, and selecting a breaker with an appropriate amperage rating. In addition to these fundamental steps, it is important to consider other factors such as rating, interrupting rating, coordination, and future expansion. By following these guidelines and consulting with qualified professionals, you can ensure that your motor feeder circuit breaker is properly sized and installed, providing reliable protection for your motors and electrical system. Always refer to the latest edition of the NEC and any local amendments for the most up-to-date requirements and guidelines. Electrical codes and regulations are subject to change, so it is important to stay informed of any revisions or updates. In addition, consider the type of motor starter used in the application. Different types of motor starters, such as across-the-line starters, reduced voltage starters, and variable frequency drives, can have different starting current characteristics. These starting current characteristics can affect the selection of the appropriate overcurrent protection device. It is also important to consider the duty cycle of the motors. Motors that operate continuously or frequently may require a larger feeder breaker than motors that operate intermittently. The NEC provides guidance on selecting overcurrent protection devices for motors with different duty cycles. Remember that proper documentation of all calculations and decisions is essential for future reference and troubleshooting. Keep records of the motor full load currents, branch circuit protective device ratings, feeder breaker size, and any other relevant information. This documentation can be helpful for maintenance, repairs, and future modifications to the electrical system. Consider the ambient temperature in which the feeder breaker will be installed. High ambient temperatures can reduce the ampacity of the breaker, so it may be necessary to select a breaker with a higher rating. The NEC provides correction factors for adjusting the ampacity of conductors and overcurrent protection devices based on ambient temperature. Also, consider the altitude at which the feeder breaker will be installed. High altitudes can reduce the dielectric strength of the air, which can affect the performance of the breaker. The NEC provides guidance on directing overcurrent protection devices for high altitude installations. When selecting a motor feeder breaker, it is important to choose a breaker that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. This ensures that the breaker has been tested and meets applicable safety standards. Ensure that the feeder conductors are properly sized to carry the calculated load current. The NEC provides tables for determining the ampacity of conductors based on their size, insulation type, and installation method. The conductor ampacity must be at least equal to the calculated load current plus any applicable directing factors. When installing the feeder breaker, follow the manufacturer's instructions and all applicable codes and regulations. Ensure that the breaker is properly mounted, wired, and grounded. Verify that all connections are tight and secure. After installing the feeder breaker, test it to ensure that it is functioning properly. Use a circuit breaker tester to verify that the breaker trips at its rated current and within the specified time. It is also recommended to perform periodic maintenance on the feeder breaker to ensure that it remains in good working condition. This maintenance may include visual inspections, cleaning, and testing. Finally, remember that electrical work can be dangerous. Always take appropriate safety precautions when working on electrical systems. Wear appropriate personal protective equipment, such as gloves and eye protection. De-energize the circuit before working on it, and verify that it is de-energized using a voltage tester. If you are not qualified to perform electrical work, hire a licensed electrician. By following these guidelines, you can ensure that your motor feeder circuit breaker is properly sized, installed, and maintained, providing reliable protection for your motors and electrical system. Remember, safety is always the top priority.